sometimes a system is set up so nicely for elimination. For instance, we have our first equation is x squared plus y squared equals 13. And our second equation is x squared minus y equals 7. I can either multiply the second equation by -1 and then add the two together, or I can simply subtract the two equations. So I can subtract equation 1 minus equation 2. If I do that, x squared minus x squared, look at that. X squared is eliminated. Y squared minus -y, y squared, let's not make this purple, y squared minus a -y, and then we have equals 13 minus 7. 13 minus 7 is 6. So we have y squared plus y minus 6 equals 0. I'm going to factor y, and then I'm going to have a +3 and a -2. That's going to get me back to a -6. And the outer and the inner gets me back to a +1y. So I've got two values for y. Y is -3 and y is 2. So when I write my ordered pairs, one ordered pair has a 3 for the y, and a -3 for the y, and the other one has a 2. Now, what are the values that go in for x? What are the values that go in for x? Well, we're going to plug these in. So which one do you think we're going to plug them into? I'm going to go with the second equation. So we're going to plug them into the second equation. When I plug the -3 in to the second equation, I get x squared minus -3, which is x squared plus 3, equals 7. Subtract 3 from both sides. We get x squared equals 4. I square root both sides, and when I square root both sides, I get a plus or minus. So when I put a -3 in, I get a +2 out, and I get a -2 out. So there were actually two ordered pairs for that one y value. Okay, let's try when y equals 2. I'm going to put that 2 in, and remember, we're going to have a plus or minus situation again. X squared minus 2 equals 7. We're going to add 2 to both sides. Well, we already know this one. Plus or minus 3, right? So I'm going to have a +3 and a -3 when y is 2. Now let's see what we're dealing with here. X squared plus y squared equals 13. That's a circle. So that is a circle. X squared minus y equals 7. That is a parabola opening sideways. Now we're going to learn this in conic sections, but you're going to see, do you see how we've got this going on right here? It's a cool thing. It's a cool thing right there. So it looks a little something like that, possibly, but you've got actually this parabola doesn't open sideways. This is a y equals x squared. This opens like this. Ugh, even better. Except that my parabola is a little lopsided. There we go. There we go. We are going to learn about parabolas opening left and right when we talk about conic sections, but this one is just a parabola that opens up, and you've got 4. Now, it doesn't mean that we would have necessarily had to have 4. If this parabola is sitting up a little bit more, you only have 2. Or maybe you have 3. Look at that. 1, 2, 3. Or maybe you don't have any. Or maybe you just have 1. It's totally off the screen right now. But yeah, that's what could happen. I could move this too. Move this down. Look at that, just 2. You just have 2. So lots of different situations that can happen, but that's the situation that actually did happen. And there are 4 answers that go with it.